Solving equations, another way to see them. One creative way to solve the equations is see all the variables as images, following the same rules. These are the rules. If some variables are adding to the variable that we want to be solved, then these variables go to the other side by subtracting, and vice versa. If some variables are multiplying the variable to be solved, then these variables go to the other side by dividing, and vice versa. Let's see this example. We need to solve the m from this equation. We can see the term PB as if it was an image, a pink triangle. The same for the other ones. The RT terms, we can see it as a blue square, and the M, we can see it as a green circle. Now that we have identified the terms as if they were images, it's easier to move them. For example, the green circle is in the bottom part of the M, the variable that we want to solve, and is dividing, so it moves to the other side by multiplying, or to the top side. You can see in the image how the green circle moves to the other side. Now, we already have only the M variable and the blue square. The second step is leave alone the M term that we want to be solved. In this case, this blue square has to be moved. Right now it's multiplying the M, so it goes to the other side by dividing the whole terms. Other way to see it is this blue square is in the top part, so it goes to the other side in the bottom part. Now that we have solved the equation for the M, now we can switch these images as the original terms. For example, instead of having the pink triangle, now it's PB. Instead of having the blue square, now we have the RT. This proposal is focused on see the group as variable, as one thing, as one image. So in the first step to solve the equation, you can move these variables as images in order to leave alone the variable that you need to solve. It is useful because sometimes there are many variables and you need to move them as a group. Let's see another example. From this equation, we need to solve the P2. So all the terms has been identified as different images. We can see the green circle, the yellow circle, the triangle, the blue square, the purple square, and we have identified the P2 with the arrow. In this case, the P2 is in the right side, so leave it in there. Do not change to the left side. This is going to make it easier to solve the question. Now we need to identify which are the terms that are or adding or subtracting the terms, the term P2. We see that the orange, the yellow circle and the purple square are adding to the P2. So it goes to the other side by subtracting, leaving alone the P2. In this example, example number 3, we need to solve Z2 from the same equation. So as you can see, we have identified where the Z2 is located. In order to solve this term, we need to identify all the terms by groups. in this case by images. And we can see that the yellow circle and the red triangle is adding to the term, to the purple term. So if they are adding, it goes to the other side by subtracting. Now we have eliminated, or we have moved the elements that were adding to our purple square, and now we can focus on the purple square to leave alone the Z2. In this case, this purple square is formed by the G, the row or density symbol, and the Z2. All these three terms are multiplying each other. But we need to leave alone the Z2. That's why the G and the density symbol needs to be moved to the other side. But since they are multiplying the Z2, it goes to the other side, dividing. In this case, the G and the density goes to divide the whole other terms. As you can see here, the G and density is dividing all the terms. You cannot put it only in one term, it has to divide the whole thing. And now finally we have solved this equation. C2 is equal to all these terms divided by G and density. Please leave the C2 in the right side. This is correct. Once that equation has been solved, now you can move the C2 to the left side if this is okay for you, or you can leave it to the right side. Thank you.